Today we're going to look at the last of the conics, which is what we call a hyperbola. And you might remember a hyperbola has asymptotes and it has two different branches. And just looking at this equation, copy down this equation in the back of your 9-4 notes. I've given you some problems, and on the back you'll just copy these general equations down. So notice that it should look very similar to an ellipse, but there's a major difference, and that major difference here is this negative sign. So a hyperbola, what I want you to just kind of get the idea of is the center of a hyperbola is still going to be HK, but watch what happens when I get a hyperbola. It's almost going to be an ellipse, but what we're going to do is we're going to turn the ellipse. Here's a vertex and here's a vertex on my ellipse. But we're going to turn this ellipse, if you can kind of imagine that we're going to turn it inside out. Instead of our curve going this way, it's going to go this way. And so our hyperbola, if you want to think of a hyperbola, is going to be inside out an ellipse. So again, we'll have some branches like we did when we were doing rational functions. We'll have two branches, and they will either go what we call horizontal in the ellipse or a vertical ellipse. And a vertical hyperbola, I just said an ellipse, but a vertical hyperbola, the branches will go up and down. Okay, and I'll kind of explain to how we can get that. But first off, let me just graph this first hyperbola. It looks like problem number 1. So let's go over to the back side. We can see that the center is going to be HK. If there's no numbers here, the center is 0, 0. So we'll go 0, 0. Like the ellipse, we'll go in the x direction, square root of 25, which is 5. So go over to 5 and go over to negative 5. And these will be what we call our vertices. So A is going to be the distance from the center to the vertices. And the number underneath the Y is how fat our hyperbola will be. Okay. Now again, you guys will probably see the ellipse. But when we see the ellipse, let me just kind of sketch it with my imagination here. Our ellipse would look like this, but we're going to turn this inside out. So we're going to have guidelines. So if you'll go one up from the vertices, this will tell you how fat your hyperbola is. I'm going to give you a ruler, and I'd like you to graph asymptotes. Remember what an asymptote is. An asymptote is the line where the curve gets closer and closer to, but never touches. And then when you graph your hyperbola, you're going to use these, connect your one away and one away through the center, and these will act as our guidelines of how to graph your hyperbola. So start at your vertex and kind of graph your curve going closer and closer to this line, but never touching, and closer to this line. And if I do that same thing over here, I'll have our first hyperbola. Now notice on number 2, we have a negative again. So this tells you that we have a hyperbola. But notice the y squared is going to be first instead of the x squared. So again, let's hesitate, go back over to the other side. And that is the only difference with an up and down hyperbola, excuse me. So we have y minus k quantity squared over a squared minus x minus h quantity squared over b squared equal to 1. Okay. So notice a in our hyperbola is always going to be with the positive variable. Okay. Or most of the time, that'll be our first variable because our second variable is negative. So we're still going to have our center. Our center here is still 0, 0. I'm going to go in the y direction 4 both ways. These are where we get our vertices. And now again, how do I know the vertices are on the y-axis? Because the y comes first. We're going to go 4 over and 4 over in the x direction, but instead of graphing in the ellipse, we're going to mark a point up here for the width of a hyperbola and graph. You can graph these in dashed or solid, either one, but these are our asymptotes that the hyperbola is going to get closer and closer to, but never touch. So take this vertex and make it get close to these asymptotes, and you'll see that this is going to be a pretty wide hyperbola. So let's just get an idea of number 3 and number 4. So let's look at 3. We know it's a hyperbola because of a negative sign. Number 4 is going to be a hyperbola because it's a negative sign. In number 3, the x comes first, so it's going to be a side-to-side hyperbola. And in number 4, the y comes first, so it's going to be an up and down hyperbola. Okay, so just get those general ideas. Now notice we've shifted a little bit here, so our center is not going to be at 0, 0, but it's going to be at 1, 2. So again, you use your same rules. If it's negative, it's really positive for our center. So go over to 1, 2 for our center, and then do like we did with the ellipse. Go in the x direction, the square root of 9. And this is where I like to put my vertices. I like to put a V right next to this point because that will remind me that I'm going side to side with my vertices. Okay. How wide is this? We'll just go 2 up and 2 down. This will kind of give us that guide line. And then we sketch in the hyperbola by using those guide points and call it good. So first check, we're going up and down. Now be careful, the x goes with the x. If it's positive, it's really negative. And the y coordinate, since there isn't any, this would actually be the center is going to be at negative 1, 0. So negative 1, 0 is right on the axis. We're going to go up 5 and down 5. I like to put vertices right there because right now I know I have an up and down, and that will remind us. How wide are we? We go over 4 because that's in the x direction. That will give us how wide the parabola is. Use these as our guidelines. And again, I like to use rulers, but you can kind of see how I just sketch those in freehand as well. And then I'm going to have a pretty wide hyperbola up and down. Again, let's check. Why is it up and down? Because the y squared is positive.